Hi children. So in the previous video we discussed up to the first concept totally we discussed, no? So in this video we are going to discuss about that the second concept, that is nothing but compound angles. So children, already we know about that trigonometry, right? In that earlier classes, in 8th class already we learned about that trigonometry, that is trigonometric ratios. Actually in that trigonometry we have that 4 parts here. Okay, so the first one is trigonometric ratios. So trigonometric ratios, after we have that compound angles. So compound angles, after we have that multiples and submultiple angles. After that transformations. So these 4 also parts of that trigonometry. So after completion of these 4 parts, we will discuss about the trigonometric equations. Okay, this is the order of the trigonometry. Okay, one by one related to another concept. So the first concept, trigonometric ratios, already we discussed in that 8th class. Right? So in that continuation, compound angles we are going to learn in this class. So before going to discuss about that compound angles, what is the definition of compound angle? What is the meaning of that compound angle? So here, the algebraic sum of two or more angles. The algebraic sum of 2 or more angles is called a compound angle. Okay, so what is the definition of compound angles? The algebraic sum of 2 or more angles. So in the trigonometry, what we learned? Just sine 60 degrees, sine 30 degrees, sine 90 degrees. So like that, indivisible angles we discussed. Sine A degrees, sine B degrees, like that. Okay, but here compound means this is the algebraic sum of 2 or more angles. So previous we discussed about that in trigonometry, sine 30 degrees, but here sine 90 we can write it as sine 60 plus 30. So that is the sum of 2 angles. And in the same way we can take that negative angle, then we will get it as subtraction. Okay, so here example A plus B. Next, A plus of minus B, which is nothing but A minus B. And here, 2 or more angles, A plus B plus C, or A plus of minus B plus C, which is equals to A minus B plus C, or A plus B plus of minus C. So, A plus B minus C. Okay, like this, so many angles we can take here. So that's why here what is the definition? The algebraic sum of 2 or more angles. Okay, 2 or more angles is called a compound angle. So ma'am, here you written just A plus B. Then how you are saying compound angles? So sine 30 degrees. 30 degrees is the angle. To that we are giving that name trigonometric ratios. We are adding to that. So that's why we will call that one as sine 30 degrees. Okay, so to this compound angles also just we have to write that its suffix prefix we have to write it as trigonometric ratios. So here we can write that cos of A plus B. We know that cos A degrees, cos B degrees, which means cos 30 degrees, cos 60 degrees, cos 45 degrees, cos 0 degrees, cos 90 degrees. Okay, indivisible degrees. Okay, but here cos of A plus B and sine of A plus B. Like that only, some other ratios, sine, cos, tan, tan of A plus B, or tan of A minus B, sine of A minus B, cos of A minus B, and so on. Secant of A minus B, so many values there, no? So we can apply that, but mainly we can apply that as sine, cos, tan, and cot of A plus B. Okay, these 4 values we can use here. So sine, cos, tan, cot of A plus B or A minus B, whatever it may be, depends on that given question. Okay, so this is the definition of that compound angles. Okay, so here first we will discuss about that one of the proof, which is very important proof. By using that proof we can find that the leftover formulas also. Okay, so to derive that formula, how to derive that one we will see next. See here. So here we will discuss one of the theorem. What is that theorem? If A comma B are any two angles, those two also belongs to any real number, then here cos of A plus B is equal to cos A cos B minus sin A sin B. What is the formula here? Cos of A plus B is equal to cos A cos B minus sin A sin B. Here this is the proof, that one only given in your material also, but I will tell you here very easily. See, so cos of A plus B is equal to, the formula is cos A cos B minus sin A sin B. Okay, how it will be? Okay, let us see that. So proof here, first we have to take that, take a unit circle. Take a unit circle at the center as origin, or with the center as origin O. Okay, so take a unit circle. Unit circle means here the radius is 1 unit. The radius is 1 unit. So take that one of the circle. Take that one of the circle. Okay, with that x-axis and y-axis. Okay, why? Because here with that center as origin, where we can say that origin is the intersecting point of x-axis and y-axis. Already we learned in that coordinate geometry, right? So this is that O. Okay, and here this is x-axis, this is y, this is x dash, and this is y dash. We know that coordinate geometry, right? So here they are saying that take a unit circle. So here this is 1 unit distance it is. Okay, this total one has 1 unit distance here to here. So let it be some point as P. Okay, now here the x-axis meet at the point P on the circle. X-axis meet the circle at the point P. So here what are the coordinates here? Point P. So here this is unit distance I am saying. So x-axis, on the x-axis the distance is 1 unit. So O to P, here this is 1 unit. So x-axis is 1 and on that y-axis there is no point, no, so that's why that is 1, 0. That point is 1, 0. So point P 1, 0. Clear? Now rotate OX ray in anti-clockwise direction. In anti-clockwise direction. Okay. So what is the meaning of that? Here x-axis, angles how to find, we know that already we discussed in that trigonometry, right? So if that axis or terminal ray, that one rotates in anti-clockwise direction, then we will get that positive angles. If that ray, that terminal ray rotates in clockwise direction, so this is clockwise direction and this is anti-clockwise direction. I hope all you know this about this one. Okay, that is anti-clockwise direction. So if you rotate that terminal ray in anti-clockwise direction, then we will get that positive angle. How we can say? Because this is 0. Okay, if you rotate in anti-clockwise direction, now this one value is 60 degrees. Now this is 90 degrees. Now this is 180 degrees. So the value is in increasing order. Increasing order means that is a positive angle. Okay, if you rotate in clockwise direction, then you will get that negative values. Why? Because this is 90 degrees, we know that. If you just rotate in clockwise direction, here this is 60 degrees. So 90 to 60. Next, that is falls to 0. So 90, 60, 0, that is in decreasing order. So the level of that, the value of that angle should be in decreasing order here. Okay, decreasing order means that is negative angle. Okay, so here just rotate OP in anti-clockwise direction. In anti-clockwise direction and meet at the point Q. Okay, anti-clockwise direction and meet at the point. Meet at the point. Meet at the point Q. So here we have to write that values also. Here with the angle as a positive angle, let it be some A, capital A. Here one of the angle will be formed, no? So that is, let it be some A, positive angle only, no? So here the coordinates are cos A, sin A. Why? Because here some angle is there. To that angle, we know that how to write cos angles, how to add the trigonometric ratios. Okay, here A is one of the angle. To that angle, we are giving that cos and sin trigonometric ratios. So here the point Q is cos A, sin A. Okay, meet at the point Q with a positive angle A. With a positive angle A. Okay, next, again rotate here OQ in anti-clockwise direction. Okay, again rotate OQ in anti-clockwise direction. Then here meet at the point some R. Okay, clockwise direction and meet at the point R on the circle. So here what are the coordinates of R here? So here one of the another positive angle is B. So always we have to check that angle as OP, OQ. Okay. So this total angle we have to observe that. So that's why here the angle is cos of, here AB, two angles also there, no? So cos of A plus B, comma, cos of A plus B, comma, sin of A plus B. Okay, two angles we have to take here. Why? Because here always we have to consider with the x-axis, no? So from that x-axis onwards, if you rotate that terminal ray, then we will get that angle as A. So here we written that cos A and sin A. If you rotate the same ray up to here, okay, same ray up to here. Here I taken that a B value. Okay, one of the B angle. Here this is A angle. So only this one I taken B, this is A. So what is the total angle? Total angle is A plus B only, no? So that's why here the coordinates are cos of A plus B and sin of A plus B. So that those two are the coordinates of R. Did you understand? Yes. In continuation, now rotate that OX ray or OP ray. Rotate that OP ray. On that OX we have that OP is another ray, no? OP ray in clockwise direction and meet the point S on the circle. Meet the point S on the circle. So here that is rotating in clockwise direction. Clockwise direction means a positive angle or negative angle. Negative angle only, no? Clockwise direction. So that's why this one I am going to take it as minus B. Okay, that one I am going to take it as minus B. Okay, or let it be some B only. This one also take it be some B. But here that is rotating in a clockwise direction. No, so that's why here we can consider it as minus B. Cos of minus B, sin of minus B. Okay, and here we know that cos of any negative angle is always positive. So here this one become as cos B. And sin of any negative angle is always minus sin. So minus sine B. So these two are the coordinates of S. Okay. So what is that point we didn't write now here? So R point as cos of A plus B, comma sine of A plus B. Okay. Again, now rotate. Now rotate OP ray in clockwise direction. Clockwise direction. With the angle B. With the angle B. And meet the circle at the point. Meet the circle at the point S. Okay. So what are the coordinates of S here? Already we know that cos B, comma minus sine B. Okay. What we did in that circle, that one only I written here. Okay, children. Up to here we did that. Now, after what we have to do? See the diagram. So, if you join that R and P, if you join that R and P, here we can observe that OPR. Join R and P. Okay. Now, here we can observe that one of the triangle, that is OPR. Now, join P and R. Now join P and R. Then triangle POR will be formed. Okay. If you join that P and R, then POR triangle will be formed. And in the same way, join. Here we can join that S and Q also. Now join that S and Q also. Okay. Here we can observe another triangle, that is OSQ. What is that another triangle? That is OSQ. Join Q and S. Join Q and S. Then triangle SOQ will be formed. SOQ will be formed. Okay. So just observe that. Here by observing this one, here unit distance I am saying no. So here RP is equals to QS. Okay. And in the same way, OQ is equal to, here we can take that OR. Okay. In triangle ORP or POR. In triangle POR and triangle SOQ. Okay. Here we can say that. So children, see here. Here we can observe that two triangles, no? One is POR, another one is SOQ. So here we have the two triangles, and we learned about that congruent triangles in the previous classes, no, 7th class. Already we discussed about that congruent triangles. So here congruency, some rules there, no? SAS congruency, AAA congruency, SSS congruency, RHS congruency. So once check that which congruency this one follows. Okay. So just observe that OR. By seeing the circle, here OR is one of the radius. OR is radius. OP is also radius. At that starting only we written here, take a unit circle. Unit circle means here radius is equals to 1 unit only, no? So center to any point on the circle, that one is called radius. So center to any radius here. If you draw that any radius, its distance is 1 unit only, no? So that's why here we can say that OR, that is equals to here OP. Okay. So in this triangle we are talking, no? So these two are equal means here we can say another thing. OQ is also another radius. OQ, that is also one of the radius. So OR is equals to OQ. Shall we say like that? Yes, obviously. Why? Because those two also radius only, no? So radius always same, right? Okay. So that's why here from these two triangles we can say that OR is equal to OQ. So first one, OR is equals to OQ. So I'm going to write this one here, see. OR is equals to OQ. Or OR congruence to OQ. Next, another one. Here we can say that another one, OP, and here in this triangle I am going to take this one as OP, and here I am going to take this one as OS. Those two also radius only, no? So those two radius also equal. From this triangle POR I am going to take it as OP, and here QOS, from this triangle I am going to take it as OS. Those two also same only, no? Why? Because those two also radius, its measurement is 1 unit. Okay, so that's why here PO or OP. PO is congruence to SO. Okay. And here we can observe that one of the angle also. What is that? Angle ROP. Angle ROP is equals to, here observe that angle I am drawing. Angle ROP is equals to, we can take that A plus B angle here. I am going to talk about that angles. So, angle ROP or POR. Here angle is A plus B. Angle POR is equal to A plus B. Okay, this angle we know that. And in the same way, another angle also we can observe that. What is that? Angle SOQ. This is also A plus B only. Here A is there, here B is there. So this total angle SOQ is also A plus B only, no? Okay. So that's why here angle SOQ is also A plus B only. So from this one what we can write here? Angle POR is congruence to angle SOR. So children, from this one here we can observe that two sides, OR is congruence to OQ, that is one of the side, and PO is congruence to SO, that is the second side. So these two sides also congruent, as well as one of the angle also congruent. So by which congruency we can say that? By two sides S and S. So one of the angle, including angle equal, no? So that's why by SAS congruency. SAS congruency, triangle PO. What is the triangle here? Triangle POR SOQ. Triangle POR is congruence to triangle SOQ. Okay? By using that congruency. Don't be confused, children. One by step you have to observe. So here these two are equal by CPCT, corresponding parts of congruency triangles are equal, no? So if that those two sides are equal, those two angles are equal, then here we can say another thing also. What is that? If two sides and angle equal means automatically the third side of the triangle also will be equal. The third sides of that or the third hands, here third arms we will talk, no? So those sides also will be equal. So what is the third side here? So the third side is here. This is QS. QS is one of the side, that is equals to RP. Okay. So PR is equal to QS. So by CPCT, we can say that PR is equal to QS. PR is equal to QS. So here this is distance only, no? So from this one we can say that PR square is equal to QS square. Okay. So those two lengths are equal means those 2 points, we have that points in coordinate system. What we can say here, P and R, 2 points there, then that is equals to QS. So here to find that distance we can find out, no, here. So P and R points we know that. So how to find the length of that line? By using that distance formula. Yes or no? So before going to that, first we have to write that what are the points. Okay. So PR square is equal to QS square. So first I am going to write that the points P, R, Q, S. Okay, these points first I am going to write. So P point already we know that 1, 0. Next R point. So what is the point at R here? Cos of A plus B, sin of A plus B. R point is cos of A plus B, comma sin of A plus B. Okay. Next Q point. What is that point at Q here? Cos A, sin A. And here S point is cos B minus sin B. So here cos A, sin A. This is cos A, sin A. And the next point is cos B minus sin B. Okay children, these are the points. Now by using these points we have to find that distance formula here. Okay, so what is the distance formula? To find the distance of, by seeing this one we can say that a distance of PR is equal to distance of QS. Okay. So what is the formula to find that distance? Distance formula, distance between any two points. So what is the formula here? Square root of x2 minus x1 whole square plus y2 minus y1 whole square. So this is the formula we have to apply. Okay, so but already here we taken that is squares, no? So if you apply here squares, then square and root gets cancelled. So that's why here now PR whole square is equals to QS whole square. Okay, so that's why I'm not writing here square roots. Why? Because square roots will be cancelled, no? So that's why. So here x2 minus x1. So first P and R. So P and R values. So this is x1, this is x2, y1 and this is y2. By seeing that, tell me now. So quickly write. See here x square. So sorry, PR square. So PR square means x1 value or x2 value. Anyway you can consider it. Why? Because whole square is there, no? So anyway you can take that. So x2 value. So what is the x2 value here? Cos of A plus B. Cos of A plus B. That is x2 minus x1 is 1. So x2 minus x1 whole square plus y2. So what is the y2 here? Sin of A plus B y2 minus y1 is 0 whole square. Okay, so this is the distance of PR whole square, which is equals to QS. Now here these two. This is again x1, this is x2. y1, y2, which is equals to x1 cos A minus cos B whole square. x2 minus x1 or x1 minus x2, anyway we can take, no? So that's why. So cos A minus cos B whole square, x1 minus x2 or x2 minus x1 whole square plus y2. So what is y2 here? Minus sin B. So y1 minus y2 also we can take, no? So take this one as sin A, y2 minus y1 or y1 minus y2. y2 is minus sin B whole square. y2 minus y1 whole square. Okay, am I clear? So now see here what you will get. So x2 minus x1, y2 minus y1 whole square. Now we have to simplify this. Okay, so this is the largest theorem only, but we have to learn. Okay, and important theorem. So cos of A plus B minus 1 whole square. This is in the form of A minus B whole square form. So A minus B whole square formula is A square minus 2AB plus B square. Okay, so apply that formula here. So A square cos square of A plus B, A square plus B square which means 1 square minus 2ab. 2 into 1 is 2 cos of a plus b. Cos of a plus b minus 1 whole square is cos square a plus b plus 1 minus 2 cos of a plus b into 1 plus sin of a plus b minus 0. So no need to consider it. So this one is sin square of a plus b. Sin square a plus b. Okay, now see here. Cos square of a plus b plus 1 minus 2 cos of a plus b plus sin square a plus b. So here cancellation terms not there, but we can write that cos square of a plus b and sin square of a plus b together. Why? Because that is in the form of sin square theta plus cos square theta. So here we can write this one as LHS we are doing, no? So cos square of a plus b plus sin square of a plus b. Okay, we can write together. Next, the leftover plus 1 minus 2 cos of a plus b. Plus 1 minus 2 cos of a plus b. Okay, so from this one here we know that the condition cos square theta plus sin square theta trigonometric identity which is equals to 1. So by using this identity here, substitute that value here. Cos square of a plus b plus sin square of a plus b which is equals to 1 plus 1 minus 2 cos of a plus b. So from this one, 1 plus 1 is 2 minus 2 cos of a plus b. Okay, so from this 2 also we can take that 2 as common. So 1 minus cos of a plus b. This is LHS. Now RHS. Okay, so LHS we got this one. Now RHS value. So what is that RHS here? Cos a minus cos b whole square plus sin a minus of minus sin b whole square. So write that one, cos a minus cos b, cos a minus cos b whole square. And here sin a minus into minus, that is a plus only, no? So sin a plus sin b. So sin a plus sin b whole square. Now simplify this. This again in the form of a minus b whole square, no? So cos square a minus, sorry, plus cos square b minus 2 cos a cos b. Okay, plus here this one sin square a plus sin square b plus 2 sin a sin b. Okay, so just see here. Here cancellation is not possible, but again we can write in the form of trigonometric identity sin square a and cos square a. So we can write this one as cos square a plus sin square a plus here cos square b sin square b, cos square b plus sin square b. Okay, so after completion of that, here minus 2 cos a cos b minus 2 cos a cos b, and here plus 2 sin a sin b. Okay, so here we know that cos square theta plus sin square theta is equal to 1, cos square theta plus sin square theta is equal to 1. So from this one we can write that 1 plus 1 minus, from these two terms also we can take that 2 as common, no? So take that minus 2 as common. Okay, so minus 2 of cos a cos b, and here plus become as minus sin a sin b. Almost completed. Okay, so 1 plus 1 minus 2 into cos a cos b minus sin a sin b. So finally we will get it as 1 plus 1 is 2 minus 2 minus 2 into cos a cos b minus sin a sin b. Okay, this is that RHS. Okay, and we know that LHS is equal to RHS, no? Now LHS is equal to RHS. Okay, so what is that LHS here? So LHS we got it as 2 into 1 minus 2 into 1 minus cos of A plus B. 2 into 1 minus cos of A plus B. Okay, which is equals to, what is that? Again from this 2 also we can take that 2 as common, no? So if you take the 2 as common, then here 1 minus here brackets of cos A cos B minus sin A sin B. Okay, so from this 2 also we can cancel that 2 and 2 gets cancelled. Okay, so after that 1 minus cos of A plus B is equal to 1 minus of cos A cos B minus sin A sin B. Okay, so here 1 and 1 gets cancelled, as well as here minus, and here also minus gets cancelled. So from this one, cos of A plus B is equals to cos A cos B minus sin A sin B. So up to here this formula will be completed. Okay, so this is the proof, hence it is proved. Okay, this is a long process only, but very easy. If you understand that step wise, this is very easy. Okay, so once again see that. So first we have to start from here onwards. So what is the theorem? If AB belongs to R, then cos of A plus B is equal to cos A cos B minus sin A sin B. That one we got it last, no? So first what we have to take? First, what is the process? That process we have to write. What we are doing with that circle. Okay, that circle also unit circle. What we taken and what we are doing with that circle. Everything we have to write here. Okay, so first we taken that circle. Okay, after we taken that x-axis and y-axis, and x-axis meet with the point O with that P, that is the point 1 comma 0. So after if you take that terminal ray, rotation ray, okay, if you that rotate in anti-clockwise direction, then we will get positive values. If you rotate that one in clockwise direction, then you will get that negative values. So after by using the trigonometric ratios, here we can write that coordinate points. So after here we have to observe that two triangles will be formed. Those two triangles also we can apply that congruency rules. Why? Because here radius is always 1 unit in that circle. Anywhere if you take, the radius is 1 unit. Why? Because we take in unit circle. Okay, first only we mentioned that. So that's why here by using congruency rules, by applying that congruency rules, we can say that two triangles, which two triangles are formed, those two are congruent to each other. Okay, so that's why here those two are congruent to each other. That's why another third side, if two sides and including angle are equal in the two triangles, automatically the third side also equal. Okay, so by using that condition, okay, third sides are equal means its squares also equal. Okay, so PR and QS, those two we can consider it as distance between 2 points also. Why? Because here we have that points of P, Q, R, S, those all also having that some coordinate points, no? So that's why here we have to find that the distance. So distance between these 2 points and the distance between these 2 points. Okay, those two also equal, no? So that's why. So after that, apply distance formula here. Okay, just write that the coordinate points. Just take that x1 and x2, y1 and y2 values, and here you can take that x1 and x2 as x1 minus x2 or x2 minus x1, anyway you can take. Why? Because whole square is there, no? So negative will come means again it will become as positive. So anyway you can write that. So after simplification, finally we will get that answer as cos of A plus B is equal to cos A cos B minus sin A sin B. This is very important proof. Okay, important theorem. Clear, ma? So in this video we discussed about this one, no? So here onwards no need to write proofs for everything. Okay, this much of proof not required. Just we have to substitute the leftover formulas. By using this one we can find that remaining any formula. Okay, so if you learn this formula, we can write that so many formulas by using this one. Okay, so in the next video we will discuss about that next continuation class. Okay.